Okay, so the previous video looked at conditional probability, and we're just going to move on and revisit that formula which we saw in conditional probability, and look at another formula as well which can link unions and intersections. Okay. So there are two formulas that are very useful in probability in year 13. The first is the addition formula. So what does it actually say? It says the probability of A or B or both is the probability of A plus probability of B minus the intersection. And if you sort of think about it, it makes sense. If you were to think of a Venn diagram and you want to find the value of the two circles and the intersection, well, what you do is you do probability of A plus probability of B, but obviously you've got lots of intersections, so you have to take away one of them. So that is the addition formula there. And the reason why it's called addition formula is because it involves addition. The multiplication formula we've actually seen on the previous video. It deals exclusively with conditional probability. Okay, and we've already looked at that. Okay, so using these two formulas, let's try and answer these two questions here. The first one, relatively easier than the second one, but let's have a go. So A and B are two events such that the probability of A equals 0.2, probability of B equals 0.6, and the probability of A given B is 0.3. So using that, we have to think, what's the probability of A and B? So we've been given a conditional probability. I've got these two null probabilities here and want the intersection. And if I look at my formula, well, I can sort of adapt this to get what I want. So if I look at this formula, what values do I have? I've got A and B, probability A given B, which is 0.3. I know the intersection is what I want to find, and I know the probability of B, it's 0.6. So if you multiply through by 0.6, you get the probability of A and B to be 0.18. Okay, so that's part A done. Next question, what's the probability of B given A? And now guys, some students make some mistakes with this. They think, oh, probability A given B is the same as probability B given A. That's not the case, okay, because there are different values of probability. So how do I find probability of B given A has already occurred? Well, I can just edit this formula. So if you notice, the A was there and the A was there, instead I'm going to have B and B. And if you notice, B was there and B was there, I'm going to have A. So what's the probability of B and A? Well, we already know that. That is not the same as probability A and B, so it's 0.18 over the probability of A, which is 0.2. And when you do that in a calculator, you get 0.9. Okay. And the last one, on question 1, what's the probability of A or B or both? Well, obviously the multiplication formula does not deal with the union probability, so we need to use the addition formula here. Probability of A or B or both, that's probability of A, which we know, 0.2, plus probability of B, which is 0.6, and probability of A and B, which is 0.18. And when you figure that out, you get your answer to be 0.62. Okay, so that's question 1 done. Okay, right, the next question, again, we're going to be using the formulas, and we're going to see if we can answer this. Fold this actually to make life a bit easier. Okay, so events A and B are two events such that the probability of A is a third, probability of B is a quarter, and the probability of the union A or B or both is 5/12. Using that, find these probabilities. Okay, so the first question is, what's the intersection value? What's the probability A given B's already occurred, and what's the probability B given A's occurred? So remember, what have I got here? I've got probability A, probability B, and I've got the union. Well, if I use the addition formula, I can probably get that. So I'm going to use the addition formula. I know probability A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So if I fill in the values that I already know, 5 over 12 here, a third plus a quarter minus the probability of A and B. With a bit of work, you can get the probability of A and B to be equal to a sixth. Okay. Part B. What's the probability of A given B's occurred? So probability of A given B, or we can use the multiplication formula as the probability of A and B over the probability of B. Okay, and the probability of A and B is equal to a sixth. We've already found that out. Over the probability of a quarter, so a sixth divided by a quarter, and you get 4/6, which is 2/3. Okay. And the final question, what's the probability of B given A? Okay, well, we can just use the formula again. So probability of A and B over the probability of A. Got to edit it slightly. That's going to be a sixth over a third, which will be 3 over 6, which is equal to a half. Okay, so that is the essence of the probability formula, the addition formulae and the multiplication formulae. Page 29 of the textbook, exercise 2D. You can have go at some of the questions there.